Hello all, welcome to Tech Capture. So in this video, we are going to see what are the different storage services provided by Google Cloud. So this video will be very helpful if you are going for Associate Cloud Engineer certification or a Professional Cloud Architect, that is PCA, or Professional Data Engineer certification. So most of these are services hold majority of the questions on the storages. Okay, so we'll see one by one what are the different storage requirement first, and for that requirement which all database services or storage services available in Google Cloud. So I'll go to next slide here and I'll first show you what are the different requirement we'll get when we are working on a Google Cloud architecture or a design of application on a Google Cloud. So these are the different storage requirement you will get when you are working on a Google Cloud or when you are designing the application using a Google Cloud. So first is the object storage. So you can treat anything as an object, like just take an example, your audio file or your video file. So when you are uploading multiple audio files somewhere, so these audio or video files are independent from each other. So you can just individually upload these files or objects. So that is called object storage. So we'll see what are the different object storage we have in Google Cloud, which can be used for storing your CSV file, your large files, or your audio, media, MP3 files. So what are the options available in Google Cloud? Then we'll have a block storage. So block storage, you can take example of your laptop. So whenever you buy any laptop, you will get one hard disk along with your laptop, and that hard disk will have all your OS installed on it and all your programs and feature installed on that operating system. And suppose if you need additional storage, you can use additional pen drive or additional hard disk. So that is just like a block of the storage. So in GCP also we'll have multiple features for such block storage, which we can just attach to the virtual machine and increase our storage. So we'll see what are the different options of a block storage available in GCP. Then we have relational storage. So for relational storage, you can consider a traditional databases like MySQL, SQL Server, or a PostgreSQL. So what are the options available for relational storage in a Google Cloud, or if you want to migrate your application from on-premises SQL Server to the Google Cloud, then what are the different options and how you can migrate your application on a Google Cloud with a SQL Server. So we'll see that as well. Then NoSQL database storage. So NoSQL storage are like your document database or unstructured data. So what are the different storage services available for your unstructured data in Google Cloud? We'll see that. And for data warehouse, so just take example, if you are using your online banking and you want to download a bank statement for last 1 year, so you can download it using your online banking. But suppose you want to download the statement which would be 5 or 10 years longer, then you cannot download from your online system because that data is not available in your transactional database. So that data will be available in your data warehouse. So whenever there is a transactional data which cannot be used on daily basis, but we have to store that historical data. So as per the government guideline, you cannot delete, or a bank cannot delete your transactional data. So even if you are asking for a 25 years old transaction to your bank should able to provide that transaction details. So even though no one will ask, but they have to maintain that historical data. So for such kind of data, they will use a data warehouse. So that data won't be used for daily basis, but that can be summarized and used for analysis or analytical purpose. So that is called a data warehouse. And then we'll have in-memory database. So in-memory databases will be used where the speed is important or latency is important for your application. So just say example of a gaming application. So if your game is lagging or the transaction in your games or operations are lagging, then there won't be much fun. So for such system, there will be a high speed database required, and in such cases in-memory database will be used along with your main databases. So these are the different storage requirement we can get while working on a cloud architecture or designing application on Google Cloud. Now we'll see all these storage system one by one and available solutions, their features, and what are the alternate options also we have on pricing as well. So we'll see all these one by one. So first we have object storage. So in object storage, we have a service called Google Cloud Storage or a GCS bucket. So this is very similar to S3 bucket in Amazon and object storage in Microsoft Azure. Okay, so you can just correlate that service if you already having knowledge of AWS or Microsoft Azure. Okay, so what is cloud storage? So okay, one more thing. So whenever I am showing you all these slides, so I'll make few words as a green, and these words can be helpful in your exam when you are eliminating the wrong answer or you are finding the correct answer. So you have to just remember this keyword before going to exam, and you will get answer to the most of the question based on this keyword. So I'll explain you at the end of this video how you can pass this exam or how you can find these services suitable for your requirement in exam based on these keywords. Okay, so first we'll see what is cloud storage. So this is managed service for storing unstructured data. So unstructured means your data can be your PDF files, your CSV files, which can be unstructured, or even empty file, or your audio files, your media files, your MP3 files, MP4 files. So any kind of data you can just store in your Google Cloud Storage. So I'll show you on Google Cloud Console how this Google Cloud Storage looks like if you are new to GCP. But again, so this Google Cloud Storage is best for image, media, backup and archival. So even if you have old files, so as I said, I was giving example of bank transaction. You just take an example of your files also, or a data file. So you have files which contains the transactional data on daily basis, and you want to store that file for a longer time, so you can just upload that file to the storage bucket and you can store that for a longer time in archival. So that how we can maintain the security and encryption, that parts come will later, so we are not considering that part here now. We'll mostly considering the storage services here. So we'll see what is the pricing. So as here it mentioned, it is a very reasonable pricing. So here you could see for every users or the project there will be 5 GB of regional storage free. So if you are creating your GCP account free trial also, or even a billing account, so you won't be charged for your first 5 GB. And there are different storage classes. So these storage class are depend upon how long you are storing the data. So if you are storing the data for longer time, there will be less charges. So it depend upon your type of operation you are doing. So suppose if you are writing data on daily basis in a particular storage bucket or a particular file, then you have to use the standard storage. Nearline storage, if you are accessing data infrequently, just say once in a month, then you can use this nearline storage. And if you are not accessing data at all for a longer time, let's suppose uh, 90 days or something, or once in a 90 days, then you can go for cold line storage. And archival is just like you will access only in a particular event, so you will just store your database backup and you will not access that database backup until and unless there is a disaster happen and you need that backup to restore your database. In that case you can use archival storage. So that are the different storage classes. I'll go to Google Cloud Console and I'll show you how this GCS storage will look like and how we can operate on the GCS storage. So I am on Cloud Console. From hamburger menu, you just go to the cloud storage here and click on cloud storage. You will see a multiple buckets. So buckets are nothing but a container, or you can correlate it with your Google Drive. So in Google Drive, you can simply upload your objects or your files. So same way here also you can just upload the object, but first we need to create one container, just like creating a folder. So I'll create first bucket here. Without bucket you cannot store objects in your Google Cloud. So I'll just create a bucket, and bucket name I'll just give. So one more thing, so this bucket name should be unique, not in your project, it should be a globally unique. So if I am giving the test name, it won't work because this name is already taken by someone else. So I have to give some unique name. So I'll give the name based on my project ID, so that would be unique. Okay, so this is not taken by anyone. And here you can store the data on regional, dual regional, multi-regional. And if I just check for the pricing, so now you are paying for US region 0.026 per GB per month. If I go for regional storage, the price will decrease. I'll show you. Now you could see the price is for this region is 0.026, and based on the storage class also your price will decrease. Now currently I am using the standard storage class by default. So here you could see a standard storage class, that's why the price is 0.020. If I go for nearline, price is now reduced to half. If I go for cold line, price is again reduced by considerable amount. And if I go for archive, the price is very less. So you can use this storage for storing a large amount of data. And one more thing, the best feature of cloud storage is you can store any amount of data. So there is no limit to store this kind of data. So limit is only for a single object, where you can upload a single object of 5 TB. But I don't think we have a requirement to store such a huge object on the Google Cloud Storage. So once I create a bucket, it will ask you for a public access if you want to give public access for your buckets and object, and simply you can now upload the object using this feature. So this is the way you can upload any kind of file and use your Google Cloud Storage. That is the first storage option, which is object storage. Now we'll go and see for other storage option. So I'll go back to my slide and we'll explore other storage option in Google Cloud. I'll move ahead then. Okay, so block storage. So we'll see what is a block storage. So this is a reliable high performance block storage for your virtual machine instance. So as I said, you can take example of your workstation or your laptop, where you will have one hard disk attached to your laptop, and that hard disk will be used for installing your operating system, may it be Windows or Linux. So similar way, whenever we are creating virtual machine, it will be created along with one boot disk. So that boot disk is nothing but a persistent disk. And even for storing the local data, you can use a multiple disk. You can just create and attach a multiple disk to your virtual machine, and that will act as a local storage to that particular VM, and that is called a block storage. So this block storage is best useful for a local VM file storage. So suppose your configuration files, your log files, your data files, which can be used for application specific operations. So that is a block storage. And in persistent disk we have multiple options. So you could see the pricing. So standard provision space is the lowest price here. Now you might be considered that okay, these pricings you are seeing are less than Google Cloud Storage, then how the Google Cloud Storage is cheaper? So why we have to go for Google Cloud Storage if you are looking for a cheaper and long-term solution? So just take example here. Here you could see the standard provision space pricing is 0.04 per GB. Okay, so for 1 month, if you are storing 1 GB data, you have to just pay $0.04. Then how it is cheaper? So if we are going along with the persistent disk, you have to create a persistent disk with a particular size. So just take an example. If you are purchasing one pen drive or hard disk, you will either purchase for 64 GB or 1 TB, and you will give money for that 1 TB. It doesn't matter if you are using 1 GB out of 1 TB or you are using complete 1 TB. So that is not the case in Google Cloud Storage. So if you are using 1 GB, you have to only pay for 1 GB. If you are using 1 TB, you have to pay only for a 1 TB. Sorry, I missed something. We have to pay for 1 TB in persistent disk even if you are using a small amount also. So there is always a requirement for every disk type. So I will show you the requirement. So just take an example of the cheaper one. So I will go with the standard PD. So here minimum size you have to create disk is 10 GB and maximum size 64 TB. So if you are going with the cloud storage, there is no such limitation, but these are mostly used for your local VM storage. And if you are going for higher storage amount or archival, you will definitely use a Google Cloud Storage. And you can simply upload and download file from Google Cloud Storage and to do Google Cloud Storage from your VM instance using gsutil command. I'll show you in different video how we can access the files from a Google Cloud Storage using VM instance and service account. So now we'll go with the next storage type. So relational storage type. So relational storage type, you can say as a traditional databases like your MySQL, SQL Server, or PostgreSQL, Oracle, all these databases. When you are having application on this database and now you want to migrate it on a Google Cloud, so which all Google Cloud services you can use. So for this you can use a Cloud SQL, but for Cloud SQL there is one limitation. Currently it supports only three databases. Which three databases? So it supports MySQL, PostgreSQL, and SQL Server. So if you are getting question on exam like you want to migrate on premises SQL Server database on a Google Cloud, then you can say you can use a Cloud SQL option. But again, you are getting question differently on highly available solution and the global solution, then you have to go for different solution that we'll see in next slide. But always remember, if you want to use a Google managed service for relational database out of these three database, MySQL, PostgreSQL, or SQL Server, then Cloud SQL is the best option, and it provides 99.95 availability. Then what is this availability means? So this availability is based on like monthly basis, you can say. So if your virtual machine is running 100 hour in 1 month, so Google gives guarantee that your machine or your VM or your service will be up and running or available for 99.95 hours out of 100 hours. So that is the guarantee Google is giving to you if you are using that particular service. So this you can say as a good availability if you are using the application along with this Cloud SQL. And in which cases we are using a Cloud SQL, or we should use a Cloud SQL when you are designing the web application or transactional system or a microservice application or containerized application. And the costing for Cloud SQL, it differed from your requirement. So whenever we are creating the Cloud SQL instance, we just accommodate the size and compute capacity to our Cloud SQL instance based on our requirements. So I'll go to my Cloud console and I'll just show you how we can create and what are the different parameter we can choose while creating a Cloud SQL database. So let me go to the Cloud console. So I am on my Cloud dashboard, and here I'll go to this SQL. Okay, and now once we click on create instance, it will give us a three option which database we want to create. So either we can use MySQL. If your on-premises is already MySQL and you want to migrate that into Google Cloud, you can choose that database, may it MySQL, Postgre, or SQL Server. So suppose if I choose a MySQL, so it will give us latest image of a MySQL along with few previous images. And in case support your application only support a previous image and you still yet to migrate your database to the latest version and adjust the compatibility with the latest version, then you can use the previous version. So here you could see support for MySQL 8, MySQL 5.7, MySQL 5.6. So you can choose any compatible version which is required for your application. So I'll choose a latest one. I'll just give as a test password. I won't type anything, and if I just generate, it will just generate very random difficult password for me, you could see. So this is the password it will generate for me. And so configuration start with, so it will just ask, okay, you are going for production workload or it's just a development. So based on that, you could see the right side your parameter will change. So if I am going for a development, now it is just network throughput is 500 to 2000, memory is 8 GB. If I go for production, my memory is 26 GB, network output is same, storage is 100 GB again. So it will change your IOPS and your memory. Okay, so currently I'll go for development and will show you what all things we can. So here you could see the available options. You have two options, either you can create in single zone or multiple zone. So why a multiple zone? Suppose in US Central Work there are three zones: US Central 1A, US Central 1B, and US Central 1C. And you are creating your Cloud SQL instance in a single zone, that is zone A. And due to some natural disaster or any kind of disaster, zone A goes down, or there is a network outage in zone A, then your complete database will go down. In result, your complete application will go down. To avoid that, you have to be keep your solution highly available. So for that, you can create a multiple zone that is highly available. So suppose zone A goes down, your application will be available in another zone, and your database also will be available in another zone. So that is a so your application can be a regional and a multi-zonal. So you can specify zone you want A, B, C, which zone you want. You can mention the primary and secondary. Okay, so you can have to just switch the failover. There is option to do a failover. So you can refer my Cloud SQL videos and how to migrate your database from on-premises to Cloud SQL in my playlist. I'll also give the link in the description box. But this is the parameter we can choose while creating the Cloud SQL instance, and we can customize instance also to reduce the pricing. So currently, instead I don't want suppose 8 GB of memory, so I'll go for a custom memory size. So here the option is high memory. I can go for lightweight. So now it is only using 3.75 GB memory. I'll go for 2 CPU. I just want 2 CPU. Storage, now I don't want SSD, which is a good performance storage, but I don't want, I'm just testing, so I'll go for HDD. And also size, I don't want 100 GB, I'll only use 20 GB. That is fine for me, or I'll need only 10 GB for testing. So we can customize and reduce our cost using this configuration. Okay, so this is all about a Cloud SQL, and we can use MySQL, SQL Server, or PostgreSQL databases in Cloud SQL. And this is a multi-zonal database, not a multi-regional. Always remember, so if your zone A goes down, your application will be running in zone B if you configured high availability, but your complete US Central one goes down, then there is no option to make your Cloud SQL instance working in the same region. So you have to find for other option for a disaster recovery. Okay, so now we'll see what are the different options for relational databases apart from a Cloud SQL. Okay, so we have Cloud Spanner. So we'll see the difference also. What is the difference between Cloud SQL and Cloud Spanner? So this is fully managed relational database with unlimited scale. So if you are going in your Cloud SQL, we have limitation till particular size that you can scale your Cloud SQL till particular GB. But in Cloud Spanner, you can scale your database to any hexabyte or petabyte of data. So there is no scale, or there is no limit to scale your database storage or your application storage. So strong consistency. So in Cloud SQL, we have seen 99.95 of availability, but Cloud Spanner, Google is guaranteeing you a 99.999% of availability. So if your instance is running 100 hours in your 1 month, then Google will give guarantee you to it will execute for 99.999% of the time. So it is a very good high availability, and that's why it considered again bit costlier than your Cloud SQL, but it is best for scalable application where you are running on mission critical application. The application is highly critical. You don't afford to lose any of your data, or you don't afford to lose uptime. You want 100%, almost 100% of uptime. You don't afford any zonal or regional outages. In that case, you will go for a Cloud Spanner. So now we'll see the difference, major difference between Cloud SQL and Cloud Spanner, when you should use Cloud Spanner and when you should use a Cloud SQL. So if you are migrating from your existing on-premises database, it's always good to use Cloud SQL. If your database is MySQL, SQL Server, or a PostgreSQL, so you can just consider as a not MS, it's a SQL Server. If a SQL Server is a product of a Microsoft, similar this Cloud Spanner is Google native product, in-house product. So they always guarantee for a better service for this product. But I will suggest if you are migrating from on-premises MySQL, SQL Server or Postgre, then go for a Cloud SQL. And pricing, will come to this point, but first we'll see the difference in Cloud SQL and Cloud Spanner. So you should go for Cloud SQL where you have requirement till 30 TB of data. So 30 TB is again very huge for transactional databases. Where your data is up to 30 TB, you can go for Cloud SQL. So it's offers limited scalability, but it's good for lesser load. Okay, if your application is very small application, or even if it is a big and you are fine with 30 TB of scalability, then you can use a Cloud SQL, and you don't need to worry of other things like how you can migrate if you are migrating your database from on-premises to Cloud SQL. So there are native services where you can easily migrate your data. But if you want to migrate your database, or suppose you want to migrate from MySQL to SQL Server, then you have to first convert your procedures. I'm still not sure if Spanner support all the procedures from your traditional databases, but you have to convert your syntax and SQL dialects to which should support in a Cloud Spanner. So that is additional task. And if you are once on a Cloud Spanner, there is no option to go back to the MySQL or SQL Server. So that is one limitation you can see. And Cloud Spanner, it's used to store more than 30 TB of data. So it's good. If you have more than 30 TB of data, then only go for Cloud Spanner, where your application is mission critical, you are ready to pay more, but you want just application should be available always. And it is expensive service, and again, as it is a global service. So as I said, global service in Cloud SQL, we have seen we have only two options, zonal and multi-zonal. Now we'll see for Cloud Spanner what are the options. Okay, I'll go to Spanner console now. I'm on dashboard, so we'll just scroll down, more product, and I'll go for Spanner. Okay, so here I have Spanner. I'll open Cloud Spanner and I'll try to create a Cloud Spanner instance. So create a provisioned instance. Okay, so now here I'll just give the name test. Now here you could see option regional and multi-regional. In Cloud SQL, option was zonal or multi-zonal. So if US Central 1 was down, then your Cloud SQL would be down. But in case of Spanner, if you are choosing US Central 1, then your application will be distributed. I'll show you how it will be distributed. So if I am choosing any one region, I'll choose US Europe Central. Let me check other available. Yeah, I'll choose US Central 1. Okay, so if I am going for a regional US Central 1, you could see it is creating 3 read write replica in 3 separate zones. So without configuring, it's already giving us high availability in single region. It means suppose zone A goes down, there won't be any impact on your application. Your zone B will be always up. But in your Cloud SQL, you have to do a manual failover. Okay, so here that is not the case. Even zone A goes down, there will be no impact on your application. Even zone B also goes down, there will be no impact. So your application is running on one remaining zone. And suppose you have afraid that, or you are worried if all the 3 zone will go down or complete region will go down, then how your application will work. Then you can go for multi-region. In case of multi-region, you can just select, okay, I want North America, I'll go for this. Okay, now you could see it is creating 2 read write replica in Central 1, 2 read write replica in US West 3, and 1 witness in a Google private region, that is in US Central 2. So even if your one region goes down, there won't be any impact. So that is very rare case. So it means your application will be always up and running, and that's why Google provide 99.999% of availability for Cloud Spanner service. And because of all these features also, pricing is bit high, and you have to pay only for the data and compute power you are using. So let me again scroll down here. you could see the processing 100. So 100 processing unit means one node. If I go with the nodes, it will show one node, and for processing unit I can choose 100. It means one node. Okay, so this is how we can allocate a compute capacity to Cloud Spanner. Now one more important feature which will be asked mostly in exams, that Cloud Spanner supports a horizontal scaling. So what is horizontal scaling? So just take into example of vertical scaling. So if your laptop RAM is full and you want to increase the RAM of your laptop, so what you will do, you will just add additional RAM of 4 GB. Now again that also running out, you will just add additional 4 GB. So you are just adding a RAM to your laptop. So that is called vertical scaling. You are just adding compute power to the same instance. And what is horizontal scaling? So suppose your compute power is running out on a one node, you will simply add one more node. Again a second node is running out of compute power, you will just add one more node. So you are keep adding the different nodes with a new compute power. So that is called a horizontal scaling. So you will get question on horizontal scaling, then always go for a Cloud Spanner option. So that's it for Cloud Spanner. And we also seen the difference between Cloud Spanner and Cloud SQL. So that is for a relational database. Now we'll go for next databases. Now we'll see NoSQL storage options in a Google Cloud. So first is Datastore or Firestore. So Firestore is updated version of a Datastore. So I'll show you in Cloud Console. But first we'll see what is a Datastore. So this is, you could say, highly scalable document database service provided by Google Cloud, and which is best suited for mobile applications. So this service is very popular when you are designing a mobile application and you need any database in Google Cloud, then you can go for this data store, which will provide you a better speed and all functionality available for a mobile applications. Okay, so I'll go to Cloud Console and show you the difference between data store and Firestore, so you can consider this as a single service. So let me go to Cloud Console. So I am in my Cloud Console. I'll simply type here a data store, and once I go to data store, it will show prompt to either choose from data store or a Firestore. Okay, so I think I already selected data store for this project, so that's why it's not asking me for any prompt. But if you are checking for very first time for a data store page, it will ask you to choose from one data store or Firestore, and once you chosen any one of these, it will be permanent to your that project. So let me check if I have anything on other project. Meanwhile, I'm just trying to go on the data store page. Where is data store in products? Did I miss it? Let me check. Yeah, Firestore I have here. So let me go to Firestore. So this will again land me to the same page. Yeah, so you could see this project uses another database service. Your current project is just to use either Cloud Firestore or a data store. So you cannot use both in a same project. So you can always go straight to the data store page. So I cannot use Firestore in this project, so I have to go to a data store page. Okay, so that one screen I missed because I already enabled a data store in this project. Let me go back to my slide. Okay, we'll see next NoSQL database. Okay, Bigtable. So this is again a very important when you are dealing with a time series of data. So whenever you are getting questions in exam on storing user profile data, always go with Firestore as a document DB. So I'll go back here. So always remember this user profile data. So there will be questions on exam that where you will store the user profile data or the best database for document data, then you should go for a data store. But if there is a questions on time series data or IoT data, then you should always go for Bigtable. So Bigtable is highly performant, fully managed NoSQL database service for large analytical operational workloads. So where you could see it can process more than 5 billion requests per second at a peak. So you can treat this as a data warehouse as well, where you require a high amount of IOPS operations in a particular second. And you could see this is a power of Bigtable, that it can process more than 5 billion requests per second, and definitely it would be costly, but mainly it is used for time series data and IoT data, where IoT device will send number of records within a particular second to your Bigtable. In that case, you can use a Bigtable. And I'll go to a pricing of Bigtable or Bigtable page, how we can create a Bigtable node or cluster. I'll show you in Cloud Console. Okay, I'm on Cloud Console. Let me search directly from here Bigtable. And you could see the high costing on the home page itself. Yeah, now here I can create instance. So this is again a Google's in-house product like a spanner. You see the pricing here, $468 per month, and this is with 0 GB stored. So assuming there is no data, you are just created a cluster. So this is the cost you have to pay, $468 per month. So just assume the total costing if you are using with a high amount of data. So I'll just mention instance test or instance name. And here you have to select the disk type. So either you can go for SSD. So SSD is for a very good performance, and HDD where you are okay with a bit latency in your operation, then you can go for SSD. So if you choose for HDD, your pricing will reduce in your actual cost. For now, suppose I will go for SSD. I'll continue. Okay, now let me show the costing. So this is only for a compute, $460 only for a compute and not for the disk size. Now I'll show you the how costing will impact if we use SSD or HDD. So I am choosing SSD and I am storing. So currently you could see the storage cost is 0. This is only a compute cost. Now I want to store 100 GB of data. I have to pay $17 here for 100 GB of data per month using SSD. If I go for HDD, I have to just pay $2 per month. So that is how SSD will cost you based on the performance. Okay, now I'll just continue, and I want to choose this region. So I'll choose suppose Asia South 1 Delhi region, and zone, any zone randomly it will pick, and auto scaling. So how auto scaling should happen? Do we need to say okay, just adjust this auto scaling quantity, or it should auto scale whenever there is high computing power required? So it will auto scale minimum from 1 to maximum 3 nodes. I can put like 10 also here if I expect there is a high amount of load can be produced on my server. So I can just keep that auto scaling on, and I can do a manual allocation also for scaling. Based on that also our costing will impact. So that is all about a Bigtable, and mostly always remember from exam point of view. So Bigtable is used for time series data and your IoT devices to send the data. So for these two major purpose you will use a Bigtable. And again this Bigtable is used for analytic purpose also. So in next slide we'll see BigQuery, and you might get confused with Bigtable and BigQuery. So I'll try to show you the difference between Bigtable and BigQuery as well. So now I'll go to my next slide where we'll see about a BigQuery. I'll go to BigQuery now. So this is a data warehouse in a Google Cloud. BigQuery is completely serverless. Now till now where just creating cluster for all databases. For Cloud SQL, we created nodes and cluster with storage. For Cloud Spanner, we created a cluster. For Bigtable, we created a cluster. For Datastore also, we are doing allocation for resources. But for BigQuery, we don't need to create any cluster. We just need to create table, dataset, and load our data. So it just used mostly for analytical and your reporting application. So you could see it has built-in machine learning and BI that works across clouds and scale with your data. So you can load any amount of data in BigQuery as a data warehouse. So as I said in beginning of the video, given the example of a bank where we have to store, suppose we have to just keep our 5 years of data on our transactional server or a relational database server, and remaining data we have to just dump into a data warehouse. Then we can use a BigQuery where we can store historical data till suppose last 20 years, 30 years, 40 years, where we don't need to operate anything on that particular data. We won't change anything in that data, but we'll perform some analytical operation or reporting on that data. In that case, we'll use a data warehouse, and that is a BigQuery in a Google Cloud. Now always remember, Bigtable is a NoSQL database, where BigQuery is your relational database where data will be stored in the form of tables, and that is a columnar database in BigQuery. So now what is columnar database and what is features of BigQuery? You can refer my video on a BigQuery and BigQuery partitioning. So I have created a couple of videos on BigQuery, so you can refer that videos in my playlist. So whenever there is a question for petabytes of data and analytics purpose, then you can go for BigQuery as your answer, depending on other criteria as well. So you could see the BigQuery also support free tier, and you can store up to 10 GB of data per month for a free. So again, this is very cheap when it comes to storing relational data for a longer term. So I won't say a cheap, but it is good for us rather than any other database as a data warehouse. And other, you could see like a cloud storage, we have here criteria to store the long-term logical storage, long-term physical storage. So different criteria where the pricing will differ from one criteria to another criteria. So I'll just go to BigQuery and I'll show you how we can store the data in BigQuery and how we can create tables in a very short way. Now I am on a Google Cloud Console. I'll simply search for BigQuery from here, and I'll land on this BigQuery page. So at the left hand side, this is our project name. If you are working on multiple project, it will show a multiple project here. So here I can create data sets and tables. So how I can create? I simply can create data set. Here I'll just give the name of test. I'll select a location. Default it will take as a US. And once it is created, I can simply create a table inside a data set. So I can simply create a table. I can empty table or table from Google storage file or upload anything. So there are different ways to create a table. Now I'll show something along with the data. Now BigQuery stores a multiple public data set as well. It means the data from multiple organization which is available for public for their analysis. So just take an example of Stack Overflow. So you might see there are thousands or even millions of questions on Stack Overflow whenever you are browsing a Stack Overflow. So let me show you Stack Overflow once. Just keep this. Okay, now I'll go to this question. So you could see the number of question, even though there is more on that questions. So just I can add some filters or just look for any other page, but there is a huge amount of data on that Stack Overflow, and I want to access the historical data. Like suppose I want to check any questions from 2010, 2011, then BigQuery has provided a public data set So let me show you Google BigQuery. You can just type Google BigQuery public dataset. Okay, now here suppose I'll check for any public dataset. So first I will check what are the available public dataset. Okay, I'll scroll down and you will see available dataset. Okay, Google dataset. So Google Trend. So just imagine now how many users are using a Google search and what are the item they are searching. So everything Google is tracking and they are adding that data into the Google Trends dataset. Now let me show you this Google Trend dataset and how the trend is going on for Google search. So it will show, okay, what is the most key search keyword from today. So if I show you here, trends.google.com, it will show the most searched keyword in India. Okay, so now you could see the first is skin block. This is some MLA, and this will show the trend search with a search count. So this data is maintained in a BigQuery. So where we can see this data, yeah, so here we open, scroll down, and we'll see what are the available samples we have. So what are the top search terms of US for the latest available data? So I will run this query. So it will open in our BigQuery and it will show us the details as a result. I'll execute this query. Okay, and it is giving data till 25th, and then I think it's loading on a weekly basis. So these are the latest search with the rank in a Google search till the last week. So we can use this BigQuery to analyze this data. Now no one will go back and change this data because this is historical and summarized data. So this BigQuery is just used for analysis purpose where you can store huge amount of historical data. Okay, so hope BigQuery is clear now. So I will go back now and I will see what is the next available and database service in a Google Cloud. I'll go next now. So last we have in-memory database. So in-memory database we have cloud memory store service provided by Google Cloud, and it's nothing but a Redis in-memory data store to build application which will use a cache. So it's mostly used for a gaming application and streaming application where speed is important. Just take an example. For online gaming there will be a lot of users are playing and the user session management is important. In that case you have to use a in-memory database. So this database is used with along with any other databases. So that's it for in-memory database. So mostly just remember this will be used where the cache management and session management is important, and this is ideal for your gaming application. So that's all a database services in a Google Cloud. So I'll just show you a summarized view and you can just remember that, or you can just go through that before going for exam, or if you have any interview, that will help you out. So this is a summary view. So the different type of database or where do I store my data on Google Cloud. So if you have in-memory database, you should use a cloud memory store, which is good for web, mobile apps and gaming application. If you have relational database, then you have two options. One is Cloud SQL and one is Cloud Spanner. So Cloud SQL is best suited for a data less than 30 TB, and your databases are MySQL, PostgreSQL, or SQL Server. Apart from that, if your application is mission critical and you want almost 100% of availability, you are ready to pay more, then you can go for Cloud Spanner. Third, NoSQL. In NoSQL, the best document database is a cloud data store, and for time series data or IoT device data, you can go for cloud Bigtable, where it can support huge amount of IOPS operation. Then for object and block, it's separately a different database or a storage kind, where the objects data you can store on a GCS bucket. So this is most useful storage in any cloud. So in Amazon it's S3 cloud, Microsoft is I think blob storage, and other clouds also they have such kind of object storage services. So there is no limit to store your data. You can store any amount of data. It can be your media files, your audio files, video files, or PDF file, any kind of data you can store in a cloud storage. So that is very important service. And then a persistent disk, that is block storage, where you can attach the persistent disk to your virtual machine and store the data for a local VM. And last one, and we important, is BigQuery. So that we already seen, this is used for analytics purpose, BI application, and known for a data warehouse. So just one tip from my side, if you are going for a data engineer certification, then BigQuery, cloud storage are very important. There will be a lot of question on these two, their feature and all the services, and a rest of the database like Cloud SQL, Bigtable. At least you should have an overview and the introduction and feature of that services. But for cloud storage and BigQuery, you should have complete understanding, complete knowledge on these two services. You will get most of the questions on cloud storage and BigQuery for cloud data engineer certification. Okay, so hope this will help you, and if you have any suggestion from your side as well, so just let me know in comment section, or if you have any question, let me know in comment section. I will try to help you out on that. So thank you for watching this video. We'll see you in the next video.